Welcome dear audience, student and scholars. Here I'm Dr. Amjad, dear scholars. So far as we have highlighted the elements of the dynamic aggregate demand and aggregate supply, and with the help of those elements we have developed the dynamic model of aggregate demand and aggregate supply model. And now by using the model of dynamic aggregate demand and aggregate supply, we are going to study the economic fluctuations in this video. So let's discuss the introduction. Let's now use the dynamic aggregate demand and aggregate supply model to analyze how the economy responds to changes in the exogenous variables. The four exogenous variables in the model are the natural level of output Yt over bar, the supply shock Vt, the demand shock epsilon T, and the central bank's inflation target pi T static. Okay, to keep things simple, we will assume that the economy always begins in long run equilibrium and is then subject to a change in one of the exogenous variables. We also assume that the other exogenous variables are held constant. Okay, let's discuss the long run growth. The economy's natural level of output Yt over bar changes over time because of population growth, capital accumulation, and technological progress. Okay, let's see a graphical presentation. An increase in the natural level of output, then what happens to the dynamic aggregate supply and dynamic aggregate demand curve. Okay, we have income output y on x-axis, we have inflation pi on y-axis, we have a vertical natural level of output Yt over bar curve, and at this we have at that level of national income or output, and we have a downward sloping dynamic aggregate demand curve, and we have a upward sloping dynamic aggregate supply curve. And we know that the intersection of aggregate demand and aggregate supply in the presence of natural level of output will decide the equilibrium income Yt at point A and price level at point A. So when the natural level of output increases, it will shift the natural level of output curve to the rightward. So we have a shift in the natural level of output to Yt plus 1 over bar. Okay, this will shift the dynamic aggregate supply curve to the rightward. So the dynamic aggregate supply curve shift to the right. So we have a new dynamic aggregate supply curve that is DAST plus 1. So this will also rises the dynamic aggregate demand curve, and we have a new rightward shift in dynamic aggregate demand curve DAD plus T plus 1. So at this point we have also a rise in national income from Yt to Yt plus 1, and the economy is at equilibrium at point B with that amount of national income which is equal to the new natural level of output, and the price level we consider a stable inflation in the economy. So if the natural level of output increases, both the dynamic demand curve and the dynamic supply curve shift rightward by the same amount. Output to Yt increases, but the inflation pi or in price level remain the same. So this figure illustrates the effect of an increase in the natural level of output, because this variable affects both the aggregate supply and aggregate demand curve, both curves shift to the right. In fact, they both shift to the right by exactly the amount that yt over bar changes. The shift in these curves move the economy equilibrium from point A to point B. Output increases from yt to yt plus 1. Inflation remains unchanged. Okay, let's discuss the further interpretation of the long run growth. The story behind these conclusions is as follows. When the natural level of output increases, the economy can produce a larger quantity of goods and services. This is represented by the rightward shift in the dynamic aggregate supply curve. At the same time, the increase in natural level of output makes people richer. Other thing equals, they want to buy more goods and services. Okay, this is represented by the rightward shift in the dynamic aggregate demand curve. Okay, the simultaneous shifts in supply and demand increase the economy's output without putting either upward or downward pressure on inflation. In this way, the economy can experience long-run growth and a stable inflation rate. Okay, let's discuss a shock to aggregate supply. Okay, consider now a shock to aggregate supply. In particular, suppose that Vt rises to 1% for one period and subsequently returns to 0. Okay, this shock to the Phillips curve might occur, for example, because an international oil cartel pushes up prices, or because new union agreements raise wages and thereby the cost of production. Okay, in general, the supply shock Vt captures any event that influence inflation beyond expected inflation, Et pi t plus 1, and current economic activity as measured by yt minus yt over bar. So let's see a graphical presentation of supply shock. Okay, we have income output y on x-axis, inflation pi on y-axis, and we have a constant level of vertical rate of natural level of output y over bar for the all times. Okay, we have a downward sloping dynamic aggregate demand curve for all points all the time. Okay, we have a upward sloping aggregate supply curve that is DAS T minus 1. So at this time, we have intersection of both dynamic aggregate demand and aggregate supply curve at this point, point A. Okay, at this point we have that level of national income yt minus 1, and with that inflation pi t minus 1. So a supply shock in period t shifts the dynamic supply curve upward from DAS T minus 1 to DAS. So an adverse supply shock shifts the DAS curve upward to this point, that is DAS T. Okay. This new dynamic aggregate supply curve intersects the demand curve at B point. We have a higher level of inflation. This will cause the inflation to rise at pi t, and we have a reduction in output from yt minus 1 to yt. Okay, the economy short on equilibrium moves from point A to point B. Inflation rises and output falls. In subsequent period, we have T plus 1. So we have a reduction in supply that is DAST plus 1. So the economy moves to point C. At this point, we have somehow reduction in the inflation, because we have expected inflation is less than when we reach at this point. The supply shock has returned to its normal value of 0, but inflation expectation remains high. As a result, the economy returns only gradually to its initial equilibrium at point A. So these figures show the result in period T, when the economy faces shocks of supply, and the dynamic supply curve shift upward to this point, from this to this point. To be precise, curve shift upward by exactly the size of the shock, which we assume to be 1, the percentage point, because the supply shock Vt is not a variable in the dynamic aggregate demand equation, and we have no shift in or we have an unchanged dynamic aggregate demand curve. Therefore, the economy moves along the aggregate demand curve from point A to point B, as we have mentioned here. So as the figure illustrates, the supply shock in period T causes inflation to rise from pi t minus 1 to pi t, and output to fall from this point to this point. These effects work in part through the reaction of monetary policy to shock. When the supply shock causes inflation to rise, the central bank responds by following its policy rule and raising nominal and real interest rate. The higher real interest rate reduces the quantity of goods and services demanded, which depresses output below its natural level from this point to this point, which we have mentioned point A to point B. The lower level of output dampens the inflationary pressure to some degree. So inflation rises from this point to this point, and economy then moves from point B to point C, and we have somehow rise in national income from YT to YT plus 1. Okay, let's discuss here we have the numerical calibration and simulation. The text presents some numerical simulations of the dynamic aggregate demand and aggregate supply model. Okay, when interpreting these results, it is easiest to think of each period as representing 1 year. We examine the impact of change in the year of the shock period T and over the subsequent 12 years. Okay, these simulations use these parameter values. We have here YT over bar is equal to 100, and pi t static 2, and alpha is equal to 1, and rho is equal to 2, and phi is equal to 0.25, and theta pi is equal to 0.5, and theta y is equal to 0.5. Here is how to interpret these numbers is very important. The natural level of output y t over bar is 100. As a result of choosing this convenient number in Fluctuations in YT minus YT over bar can be viewed as a percentage deviation of output from its natural level. The central bank inflation target, that is YT static, is 2%. The parameter alpha 1 here implies that 1 percentage point increase in real interest rate reduces output demand by 1, which is 1% of its natural level. The economy's natural rate of interest rho here is 2. The Phillips curve parameter phi is 0.25 implies that when output is 1% above its natural level, inflation rises by 0.25 percentage point. The parameter for the monetary policy rule, here we have theta pi is equal to 0.5 and theta y is equal to 0.5 are those suggested by the John Taylor and are reasonable approximation of the behavior of the Federal Reserve. In all cases, simulations assume a change of 1% point in the exogenous variable of interest. Larger shocks would have qualitatively similar effects, but the magnitudes would be proportionality greater. For example, a shock of 3% point would affect all the variables, but the movement would be 3 times as larger as the simulation shown. So let's see the graphical presentation for this numerical calibration and simulation. In the period after the shock occur, expected inflation is higher because expectation depends on past inflation. In period t plus 1, for instance, the economy is at point C. Even though the shock variable yt returns to its normal value of 0, the dynamic aggregate demand curve does not immediately return to its initial position. Instead, it slowly shifts back downwards towards its initial position, as we have discussed in our graphical presentation DAST minus 1. So see here we have that point. Okay, as we have a lower level of economic activity reduces inflation from this point to this point, and thereby expectation of future inflation throughout this process. Output remains below its natural level. So let's see the numerical calibration and simulation in the graphical presentation. And here we have the dynamic response to a supply shock. We have here 5 parts of the graphical presentation. First one is supply shock. Second one is output, real interest rate, inflation, and nominal interest rate. So this figure shows the time path of the key variables in the model in response to shock. As we have seen that in the panel A, the shock in VT spikes upward by 1 percentage point in time period T, and then return to 0, and then return to 0 percentage point, and gradually returns to its target for 2% over a long period of time. Output shown in the panel B, see here, falls in response to the supply shock, but also eventually returns to its natural level. Okay, this figure also shows the paths of the nominal and real interest rate in period of the supply shock. The nominal interest rate shown in panel E here increase by the we have 1.2 percentage point, and real interest rate here we have a real interest rate. So a panel C here present by 0.3 percentage point both interest rate returns to their normal level as the economy returns to its natural level of output, or we can say that its normal value as the economy returns to the natural long run equilibrium. These figures illustrate the phenomena of stagflation in the dynamic aggregate demand and aggregate supply model. A supply shock causes inflation to rise, which in turn increases expected inflation as the central bank applies its rule for monetary policy and responds by raising interest rate. It gradually squeezes inflation out of the system, but only at the cost of prolonged downturn in economic activity. Okay, let's discuss the shock to the aggregate demand. Okay, now let's consider a shock to aggregate demand. Okay, to be realistic, the shock is assumed to persist, or we can say over several periods. In particular, suppose that epsilon t is equal to 1 for 5 periods and then returns to its normal value of 0. Okay, this positive shock epsilon t might represent, for example, a war that increases government purchases, or a stock market bubble that increases wealth and thereby consumption spending. Okay, in general, the demand shock captures any event that influences the demand for goods and services for given values of natural level of output yt over bar and real interest rate rt. So let's see a graphical presentation for this purpose. Okay, we have demand shock, we have income output y on x-axis, inflation pi on y-axis, and we have natural level of output y over bar for all the time periods, and we have a dynamic aggregate demand for period last year to our next year, or next fifth year. Okay, we have a dynamic aggregate supply curve upward sloping, and this is our DAS t minus 1t, and these curves will intersect each other at point A, and we have that amount of inflation in the economy by t minus 1 with that level of output in the economy yt minus 1. Okay, a positive shock to the demand will shifted the demand curve to the rightward, that is DAD t minus or t plus 1 to t plus 4. So we have the economy at equilibrium at point B with rise in output from yt minus 1 to yt. Okay, this will also raises the inflation from t minus 1 to pi t. Okay, this will create a subsequent rise in dynamic aggregate supply curve, and we have a shift in the dynamic aggregate supply curve from this point to t plus 1, and economy reaches at point C, and this will further raises the dynamic aggregate demand curve, and the economy shifted to upward equilibrium from point B to C, D, and then at point E. Okay, then further this will also raises the dynamic aggregate supply curve and at this point. So this will consider a subsequent periods higher expected inflation shift the dynamic aggregate supply curve upward from this point to this point. Okay, the last subsequent rise in aggregate supply curve will intersect the original dynamic aggregate demand curve at point G. Okay, at point G, when the economy shocks disappears, output falls, and the economy begins its return to its initial equilibrium, and we have a reduction in output from YT to YT plus 5. So we have a higher inflation IT plus 5. So this figure shows that the effect of positive demand shock in period T, the last period for the 5 years, the shock immediately shifted the aggregate demand curve from this to this. The economy moves from equilibrium point A to point B. Both inflation and output rises from this point to this point and from this point to this point. Okay, the economy moves from point B to point C, and then subsequent periods to point D, E, F, and we reach at point F. When the demand shock disappears at this point, at point G, output falls below its natural level at YT plus 5. So the inflation starts to fall. We can say that over the time, the dynamic supply curve starts shifting downward, and the economy gradually returns to its natural equilibrium at point A. Okay, let's see the shock to the aggregate demand. We have here the response to the dynamic aggregate demand shock. Okay, here we have the 5 panels for the graphical presentation: demand shock, and output shock, and real interest rate, and inflation, nominal interest rate, the 5th panel. So this figure shows that the time path of the key variables in the model in response of the demand shock. Note that the positive demand shock increases the real and nominal interest rate. So see, we have a rise in real and nominal interest rate. When the demand shock disappears, both interest rate, real and nominal interest rate, well, we can say that returns to its natural level. These responsive occurs when the central bank sets the nominal interest rate. It takes into account both inflation rate and deviations of output from its natural level. Okay, moving towards a shift in monetary policy. Okay, suppose that the central bank decides to reduce its target for the inflation rate. Specifically, imagine that in period T, T's tariff falls from 2% to 1% and thereafter remains at low level. Okay, let's consider how the economy will react to this change in monetary policy. Recall that inflation target enters the model as exogenous variable in the dynamic aggregate demand curve. When inflation target falls, the dynamic aggregate demand curve shift to the right. So let's see a graphical presentation for this purpose. We have a reduction in target inflation. We have income output y on x-axis. We have inflation pi on y-axis, and we have a natural level of output for all the period yt over bar, and we have a downward sloping dynamic aggregate supply t minus 1, and we have a upward sloping. We know that the intersection of aggregate demand and aggregate supply curve will decide the equilibrium condition of the economy at point A. At this we have the output yt minus 1 and inflation that is pi t minus 1, that is 2%. Okay, we have here a reduction to target inflation shift the dynamic aggregate demand curve downward. So we have a new dynamic aggregate demand curve that is DAD T plus 1T. Okay, this new dynamic aggregate demand curve will intersect the supply curve at point B. This will causes a reduction in output from yt minus 1 to yt, and this will also causes a reduction in inflation from this point to this point. So we have a new inflation by t. Okay, this will further have a subsequent shift in the dynamic aggregate supply curve, that is DAST plus 1. So this new supply curve will intersect the new demand curve, dynamic demand curve at point C. Okay, as in a subsequent period, lower expected inflation shift the dynamic aggregate supply curve downward. At this point we have a dynamic, the new dynamic aggregate supply curve is now this. This will eventually, the economy approaches a final equilibrium with output at its natural level and inflation at its new lowest target at point Z. So we have a inflation with 1 percentage point, and the economy has reached at its natural level of output at point Z. A permanent reduction in inflation in period T shift the dynamic aggregate demand curve to the rightward from this point, from this to this leftward, and from, we can say that DAD plus 1 to DAD minus 1. Okay, we have a shift in the leftward. We have a shift in the leftward. Okay, initially the economy moves from point A to point B. Both inflation and output, we have a reduction in output and reduction in inflation. In the subsequent period, because expected inflation falls, the dynamic aggregate supply curve shift downward. The economy moves from point B to point C in period T plus 1. Over time, the expected inflation falls and the dynamic supply curve repeatedly shift downward. The economy approaches to a new equilibrium at point Z. Output here returns to its natural level y t over bar for all the periods, and inflation ends its new low target that is 1%. Okay, here one of the main thing to discuss that monetary policy is not surprisingly key to the explanation of this outcome. When central bank lowers its target for inflation, current inflation is now above the target, so the central bank follows its policy rule and raises real and nominal interest rate. The higher real interest rate reduces the demand for goods and services. When output falls, the Phillips curve tells that inflation falls as well. Okay, lower inflation in turn reduces the inflation rate that people expect to prevail in the next period, in period t plus 1. Okay, lower expected inflation shift the dynamic aggregate supply curve to the downward from this to this, and this shift moved the economy from point B to point C, further reducing inflation, expanding output. Over time, inflation continued to fall, and we have a shift in the dynamic aggregate supply curve from this to this and till this. So we have a final dynamic aggregate supply curve for all the period. The economy approaches as its long run equilibrium at point Z, where the output is back at its natural level. We can say that final output, here we have the final output is equal to the natural level of output for the all periods, and inflation is at its lower target at final inflation rate at 1%. Okay, let's see the dynamic response to the reduction in inflation with the graphical presentation. The dynamic response to a reduction in target inflation. We have the 5 panels here: inflation target, output, real interest rate, inflation, nominal interest rate. Okay, this shows that response of the variable over time to a reduction in target inflation. Notice that panel E here, the path of the nominal interest rate IT. Before the change in policy, the nominal interest rate at its long run value of 4%. So here we have 4%. Which equal the natural level of real interest rate rho, or we can say that 2%. Here we have the 2%. Okay, plus the target inflation pi t static minus 1 of 2%. Here we have target inflation is 2%. Sorry, here we have the target inflation is 2%. Okay, when target inflation falls to 1%, so see here we have a fall in target inflation, the nominal interest rate rises to 4.2% over time. However, the nominal interest rate falls as inflation and expected, we can say that expected inflation falls towards the new target rate. Eventually, IT, we can say the nominal interest rate approaches its new long-run path of 3%. Here we have the new long-run nominal interest rate path at 3%. Thus, a shift towards a lower inflation target increases the nominal interest rate in the short run, but decreases it in the long run. Okay, let's we have On a conclusion, we close with a caveat. Throughout this analysis, we have maintained the assumption of adaptive expectation. That is, we have assumed that people form their expectation of inflation based on the inflation they have recently experienced. It is possible, however, that if central bank makes a credible announcement of its new policy of low target inflation, people will respond by altering their expectations of inflation immediately. That is, they may form expectation rationally based on the policy announcement rather than adaptively based on what they have experienced. Okay, if so, the dynamic aggregate supply curve will shift downward immediately upon the change in policy, just when the dynamic aggregate demand curve shifts downward. In this case, the economy will instantly reach its new long run equilibrium. Okay, by contrast, if people do not believe an announcement policy of low inflation until they see it, then the assumption of adaptive expectation is appropriate, and the transition path to lower inflation will involve a period of lost output. So this is all about the using of aggregate demand and dynamic aggregate supply model. So see you with another video. Ciao.